Okay, so here we go. This is another thing that you're going to want to write down that is going to be a very specific test question that we have to know, and that is the way that things that become ions, like which electrons do they lose first? So a lot of this is pretty straightforward. It doesn't matter. So S block and transition metals always lose their S electrons first. So that is going to be important because it means that when you take electrons away, they have to come from the S block before they come from any other area. Okay, well, that's not a big deal for things that are in the S block at the end, but the transition metals, this is where you're going to have a problem. Okay, now the um, the P block metals are also not a big deal because they're going to lose electrons from the P first. And so that's just not a big deal. And then, of course, if we're talking about nonmetals, well, nonmetals don't lose electrons. They're going to gain electrons. So who cares about them? So where we have to be concerned and where we have to be ready for the IB exam is right here. It's the losing the electrons first from the transition metals, which are the metals in the D block, right? So like this, you could also write down as D block. Okay, so that is what we're concerned about. So you're like, what the heck is he talking about? I don't know. Well, I'll show you. So slide over to this periodic table. Okay, so let's take a look at how this is a problem. Barium plus 2. I've got barium plus 2 up here as our starting example. Barium is going to lose 2 electrons. Okay, so that's not a big deal because barium is right here. And so barium is basically ends in 6s2. So which electrons is it going to lose? What's going to lose? The 6s2 and the 6s1. So it basically becomes a 6s0. It loses those electrons and becomes a plus 2, and it basically looks like xenon, right? So not a big deal. That's the end. That you take them off at the end. Who cares? All right. Now let's talk about something different. So let's talk about, let's look at something like zirconium right here. So let's say zirconium is also a plus 2. Okay, so let's clean this up and give us a little bit of space. So we got zirconium, and it is also going to be, oh, don't want that, want a pen? It's also going to be a plus 2. So it also is going to lose 2 electrons. So where the heck do they come from? Okay, well, here's the deal. This is zirconium. It's going to be krypton. It's going to be krypton, and then it's going to be 5s2, and then it's going to be 4d2. Okay, but we have to go back to our original rule. It says transition metals. If you don't remember what a transition metal is, the transition metals are everything in this middle area here. Those are the transition metals, okay? So it says transition metals lose their s electrons first. So what does that mean? That means it's not losing these first. Oops. It's not losing those. It's not losing these first. It's losing these first. So what happens is it loses both of those. So it basically becomes this krypton 5s0, or you could just not write it down at all, 4d2. So where did it lose the electrons? It lost them from the s. Okay, so that is only going to be for things in this area. Everything else is just going to lose from the end. So it's something that's kind of weird and kind of wonky, but you've got to be able to to navigate that. This is an exception to normal rules. Okay, so let's look at this. So normally, iron is argon 4s2 3d6. Okay, but when iron, and you might want to write this down, when iron becomes a +2, which is what that Roman numeral means, right? It means +2. When it becomes a +2, then it lost the 4s2 electrons. Those were lost, and that's how it became a +2. So let's look at lead. Okay, so lead and selenium and then zinc. So actually, let's just do selenium. Let's do them in order. So selenium is -2. All right, well, let's do the configuration for selenium. And so we're going to go ahead and slide over to our periodic table. Okay, so here's selenium here. So selenium, I'm going to clean this up, give me a little space. Now selenium is normally going to be argon. So this is a normal selenium. This is the one on the left side of your notes. It's going to be argon 4s2 3d10, and then it's going to there. So then that's going to be 4p4. So what the heck about selenium -2? Well, -2 means that it actually gained electrons. So it didn't lose them at all. So where are they going to go? They're going to go right there. They're going to go at the end, which is going to make that 4p6. Well, where's 4p6? Well, that's krypton right there. So basically, you just turn it into krypton because it becomes 4p6. So you gained electrons. So nothing fancy there. The next one in your notes is lead. So let's do lead. Keep the periodic table over here. Okay, so lead, what the heck's lead at? Well, lead's actually in the P block. And that means that it's just going to kind of act normal. So here's lead, right? And so normal lead, oops, need a pen. So normal lead is going to start with xenon. And then we're going to come down here, and we're going to do 6s2. And then we're going to do, we got to go into this is kind of a pain because we got to use the F block. So we're going to come down here. It's actually 6d1 and then 4f14. I'm not going to get real heavy into that because it's not going to matter. So this is what it looks like. It's 4f14. And then it ends up being not 60, sorry, 5d 10. And then it's going to be 6p. And then you're going to go over 2 spots. Okay, so that's your normal lead. All right, now, when your lead becomes a +2, so this is the normal lead. So when your lead becomes +2, what electrons does it lose? Well, lead is not in the middle. It is not a transition metal. So it just loses from the end. So it's going to lose these. And so those are going to go away. So it's going to become a 6p0. Okay, so now we've done the lead. And it again is nothing fancy. Just take the electrons from the end. Okay, now we're going to get into ones that are a bit of a problem. And those are going to be ones that are in the middle. Okay, so things that are in the middle are going to pose a bit of an issue. So let's take a look at those. All right, so we've got zinc, zinc +2, and copper, copper +1. Okay, zinc is right here. So here's the zinc. And the zinc is going to end in 4D10, and so we're just going to go ahead and quickly write out normal old zinc. And this is all, I'm just using the periodic table. It's all in your notes there. So we're going to go argon. We're going to go 4s2, 3d10. Normal, regular old zinc. Okay. Now, what happens when zinc becomes +2? Well, first of all, zinc is in the middle. These are the ones we got to be worried about. It is a transition metal, a D block metal. So what it does, it's going to lose these 2 electrons right here. So it's going to become this. It's going to become argon, 4s0, or you could just not write down the 4s. You could omit it, 3d10. Loses the S block first. And so that's the thing that we have to remember, is that it's going to lose S block first. Now it's only going to lose those 2 electrons. It's not going to lose all the S block, just the ones in right before it. So just these right there. Okay, so there's the zinc. So let's clean this up and let's do the last one. And the last one is the hardest one. I would tell you to be careful. It's a test question. It's the double exception. And so you end up with these rules where you have double exceptions. And this is going to be one of those situations where it's going to be a double exception, meaning that it is going to have 2 exceptions that we've looked at and not just 1. So scandium's getting, I'm just going to go ahead and erase that, wiping that out. Okay, so here we go. Let's do the last one, which is either copper or copper +1. So here we go. Copper. So let's write out copper normally. So go ahead and write copper normally out. See what you write down. So see what you do. Argon. Hopefully you did argon, right? Okay. Then hopefully you did 4s1, right? Did you do 4s1 or did you do 4s2? Why did I do 4s1? Why did I do 4s1? Well, I did 4s1 because copper is already an exception. Remember, normal copper, this is normal copper right here. Normal copper is already an exception. We talked about how it wanted the full D block, so it moves one of those electrons. Copper is already an exception, which means that your copper +1 is going to look a little weird because it's going to be a double exception. So here's copper +1. So normally it looks like this because normally it's already an exception for S1 3D10. But remember, it's also a transition metal. So when it loses electrons, which it's now losing 1 more, where does it lose? It doesn't lose from D. It's going to lose that one. So that 4s1 is going to be the one that gets lost. And so this becomes a 4s0. So it's argon 4s0, 3d10. Guys, that is a double exception. This is something that you should note is highly, highly, highly likely to be on the test. Either this one or chromium, right? So you want to know that. You want to get that A on that test. You got to watch out for chromium, silver, and copper, because all of those could be a problem. So you could have copper +2 could be a problem. You could have chromium at various charges, any of the various pluses